a machine 20 stories tall that swallowed 180 cubic yards of earth in a single bite and ran around the clock with a crew living inside it. On September 9, 1991, a hydraulic oil fire ended its reign, and almost nobody noticed. The Marion 6360 was just one of 15 forgotten machines that physically built modern America. They carved the highways, poured the dams, lifted the skylines you pass every day. Most weren't abandoned because they failed. They vanished for reasons almost no one talks about. Every mile of interstate, every stretch of city skyline, every concrete slab beneath a shopping mall, none of it appeared by chance. Beneath the surface of the modern American landscape lies the legacy of machines so vast and powerful, their very existence now feels improbable. These giants once thundered across open plains and city foundations, reshaping entire regions before quietly vanishing from view. The highways that carry millions of cars each day, the dams holding back rivers, the tunnels that snake beneath cities all began as raw ambition, realized only through the brute force of heavy machinery now absent from the public eye. Most people walk city streets or drive rural highways without ever thinking about what made them possible. Yet for every ton of concrete and steel, for every acre of leveled ground, a forgotten machine did the heavy lifting. These were not just tools. They were moving factories, consuming mountains, pouring rivers of concrete, and carving paths through bedrock. The scale defies imagination. Machines that could move thousands of tons in a single shift, some so large their crews lived inside them for days at a time. Their work transformed wild landscapes into the foundations of daily life, leaving no visible trace except the world we now take for granted. Today, the machinery that built America is rarely seen or even remembered. Their names have faded, and their forms have disappeared, replaced by smaller, quieter, and more efficient descendants. Yet every bridge, every airport runway, every city block still rests on the labor of these vanished giants. Hidden beneath the noise of traffic and the bustle of cities, their legacy endures in concrete, steel, and earth. The story of America's rise is not just one of visionaries and architects, but of machines whose power and ingenuity remain buried in the landscapes they created. By the 1920s, the sound of hissing steam and clanking gears echoed across canal trenches and city lots. Bucyrus Erie's steam shovels, perched on temporary rails, brought a new scale of power to American construction. The Model 50B, introduced in 1923, weighed in at 130,000 pounds and could lift as much as 75 tons in a single scoop. Over 500 of these machines rolled out of the factory between 1923 and 1930, each one a moving factory in its own right. On the Erie and Barge Canal projects, crews watched as the shovel's bucket bit into earth that once took 100 men days to move. Canal widening logs from the era record daily outputs near 1,500 cubic yards per machine, a leap that turned months of backbreaking work into a week's progress. In city centers, these rail-mounted giants dug deep pits for new skyscrapers, making possible the dense urban foundations that define cities like New York and Chicago. Foundation logs show a single shovel clearing thousands of tons of rock and soil per day, a pace that pushed urban construction into a new era. For the foreman on site, the arrival of a steam shovel meant more than just speed. It meant managing a crew who fed coal to the boiler, oiled every moving part, and kept cables taut as the bucket swung overhead. The machine's mobility, rolling along steel rails laid just ahead of its path, let it chase the work, carving out the next length of canal or the next city block. Operators spoke of the heat from the firebox and the deafening roar as the shovel tore into the ground, a daily reminder of the raw energy at their command. Long before hydraulics or electricity took over, these steam-powered giants set the standard for what machines could achieve. Their scale and output would soon be dwarfed by the electric behemoths of the mid-century, But the first mechanized leap in American excavation belonged to the steam shovel, a machine that turned ambition into earth and steel. The Marion 6360, known to its crew as the Captain, towered over the Illinois coal fields at 210 feet, taller than the Statue of Liberty. Its massive 180 cubic yard bucket could scoop up 150 tons of earth in a single pass. The machine stretched the length of a football field and weighed 28 million pounds, moving on 8 crawler tracks, each as wide as a city sidewalk. 20 electric motors, drawing as much power as a small town, drove its gears day and night. For 26 years, a 4-person crew kept the Captain running around the clock. The oiler, Fred Krieger, spent his shifts climbing inside the machine's steel belly, checking lines, topping up reservoirs, and listening for the faintest change in the thrum of the engines. Operators like Gene Miller steered the Captain's arm with the touch of a lever, swinging the bucket out over the pit and dropping it into the earth, while welders and ground men kept the moving parts alive. In September 1991, the routine shattered. At dusk, Krieger noticed smoke rising from the lower frame. Hydraulic oil had leaked and caught fire, spreading fast through the maze of cables and machinery. He and Miller grabbed extinguishers, fighting the blaze as flames licked at the steel. Groundman Gary Andrews scrambled onto the deck, searching for more extinguishers. But the fire was too much. Krieger pulled Andrews to safety as the blaze raged out of control. No one was hurt, but the Captain was finished. The fire made headlines across the country. Insurance covered the loss, but the machine was too damaged to repair. In 1992, salvage crews dismantled the Captain piece by piece. Nothing remains at the site but reclaimed land and the memory of a machine that, for a generation, could move a mountain before breakfast. A dragline operator sits high above the cut, hands wrapped around the levers, eyes fixed on the arc of the boom. The Bucyrus 4250W, with its 300-foot boom, stretches across a pit wider than a city block. Each cycle, the bucket skims the earth, hauling up enough rock and soil to fill a small house. The reach is staggering. No other machine could clear a span like this, moving material from places that would swallow up smaller rigs. For massive reservoir projects and open pit mines, only a dragline with this kind of arm could do the job without constant repositioning. The operator knows every creak and sway, trusting the cable lines as the bucket swings out, dumps its load, and returns for more. It's a job that demands patience, timing, and respect for the scale of the machine. But out on the highway, cuts and sprawling post-war construction sites, a different kind of force took over. The Caterpillar D9 bulldozer, first built for military use, became the backbone of America's new roads. After the Federal Aid Highway Act of 1956, thousands of these yellow machines rolled off assembly lines and onto the dirt. Unlike the bespoke giants of the mines, the D9 was built for numbers, standardized, reliable, and ready to be shipped by rail or truck wherever earth needed to be moved. A Caterpillar engineer remembers watching fleets of D9s line up at dawn, blades down, engines rumbling in unison, as they chewed through hillsides and farmland. The D9 didn't have the reach of a dragline, but it made up for it in sheer volume and speed, able to clear a path for a new interstate in days instead of weeks. The trade-off was clear. Draglines reached farther, conquering the impossible spans, but every move took time and planning. The D9s brought muscle in numbers, their strength multiplied by the thousands. Between the two, America's surface was reshaped, one machine reaching where nothing else could, the other turning raw land to the roads and suburbs that define the modern landscape. Behind each machine, a human story. The dragline operator, alone in his cab, and the engineer, who watched his designs roll out across the nation. Both knew that their machines would leave marks that would last for generations, even as they themselves faded from memory. Far below the noise of city traffic, tunnel boring machines press forward through darkness, carving new arteries for subways and water mains. The first American tunnel boring machines, rolling out in the early 20th century, were unlike anything above ground. They had a rotating steel face 20 feet across, fitted with hardened cutters and powered by electric or steam drive. Each revolution chewed through bedrock, pushing forward at a pace that made hand-dug tunnels obsolete. In the 1970s, engineers introduced earth pressure balance shields, allowing for continuous tunneling under rivers and dense neighborhoods without risking collapse above. A tunnel boring machine specialist recalls the quiet hum of the cutter head, the vibration of controls under his hands as the machine inched ahead, leaving behind a perfectly round tunnel ready for concrete lining. These machines worked unseen, their progress measured not in city blocks but in feet of rock and clay quietly displaced each day. Yet the world above relied just as much on another unsung marvel, the concrete batch plant. At Hoover Dam in the 1930s, the challenge was not only to pour concrete but to keep it coming without pause. The on-site batch plants, run by supervisors who tracked every mix and pour, could produce up to 7,000 cubic yards of concrete an hour, enough to fill a city swimming pool in minutes. Grand Coulee Dam took this even further, with 4 batch plants and a fleet of 120 mobile mixers. Supervisors coordinated a ballet of trucks and chutes, ensuring the fresh concrete reached the canyon walls before it could set, day and night, for weeks on end. At peak, Grand Coulee's plants delivered over 5.5 million cubic yards in just 2 months, setting a world record for continuous concrete placement. Both underground and at the edge of canyons, these machines operated as hidden lifelines. The tunnel boring machine engineer and the batch plant supervisor shared a common goal: keep the process moving, keep the city above, or the dam below alive and growing. Their work vanished from sight, but every mile of tunnel and every towering wall of concrete stands as proof of these relentless, forgotten machines and the people who kept them running. A dragline chief rests his hand on the battered steel of a preserved walking foot, its mechanism patented in 1913. Engineers still come to study how this giant, weighing thousands of tons, could lift itself and stride forward. The dragline's feet rock and pivot, shifting the entire machine 30 feet at a time, covering ground that would trap any crawler. In Kansas, Big Brutus, a Bucyrus 1850B, once walked across the prairie, moving 60,000 cubic yards of earth in a day. Its reach and mobility let it tackle terrain others avoided, and its legacy endures in museum yards and the stories of those who kept it running. Nearby, a Letourneau technician remembers the first 1,600-ton electric drive hauler rolling out of Longview. Unlike diesel-only machines, the Letourneau used a diesel generator to power electric motors at each wheel, carrying 200-ton payloads over soft ground at 20 miles per hour. Regenerative braking sent energy back into the system. Operators found they could haul more with less fuel and fewer breakdowns. In Alaska's oil fields and Nevada's open pits, these electric haulers cut travel times and kept projects moving, reshaping the economics of earth moving. On a bridge site, a pile driver foreman checks his logbook. 1,080 piles, driven in 6 months, each hammered deep into river mud by steam or diesel rigs. Foundations for ports, bridges, and waterfront towers all begin with the thunder of the pile driver. Without these machines, the Golden Gate's towers and New York Harbor's piers would have sunk into the silt. Every pile holds up a span that millions cross each year. At a lignite mine, an adaptation engineer points to a bucket wheel excavator spinning at full tilt. Its teeth bite into earth, feeding a conveyor that never stops. With a capacity of 12,000 cubic yards per hour, the bucket wheel moves more in a shift than a fleet of shovels in days. Licensed from German designers, this technology set new standards for continuous mining. These machines, once the future, now stand as monuments to an era when moving mountains was routine. High above the city streets, a latticework of steel grows floor by floor, each piece hoisted into place by a machine as essential as the beams themselves. The stiff-leg derrick, a crane with a single rigid leg and a web of guy wires, became the silent backbone of the 1920s skyscraper boom. On the Chrysler Building, crews relied on a derrick anchored to the rising frame, capable of lifting 25-ton steel girders from street level to the upper floors. Every morning, a rigger checked the cables, tested the winch, and signaled the all clear. The derrick's boom swung out over the edge, a steel column dangling high above Midtown, then rose steadily, guided by hand signals and the steady pulse of the winch drum. In the space of a single shift, hundreds of tons of steel would be staged from floor to floor, the derrick climbing with the building, always just a few stories ahead of the work below. For the rigger, the job was part choreography, part nerve, trusting in the strength of the cables and the precision of the crew. These cranes solved the vertical puzzle of early skyscraper construction, letting architects reach new heights and giving cities their iconic skylines. Yet as new technologies arrived, including tower cranes and hydraulic lifts, the stiff-leg derrick faded from view, its legacy hidden in the bones of the buildings it helped raise. Regulation, shifting energy priorities, and rapid advances in technology swept away the era of giant machines almost as quickly as it began. In 1977, the Surface Mining Control and Reclamation Act forced coal companies to post bonds and restore mined land, turning reclamation from an afterthought into a major expense. Operators faced costs as high as $12,000 per acre, a burden that made it hard to justify keeping machines like the Bucyrus draglines or bucket wheel excavators running. The 1990 Clean Air Act amendments tightened emission standards even further. Meeting these new rules meant expensive retrofits, sometimes over $200,000 per machine, or early retirement for fleets that could not be upgraded. Compliance costs across the industry soared into the billions, and companies began to phase out older, dirtier equipment in favor of smaller, more efficient alternatives. At the same time, the rise of hydraulic excavators and GPS-guided controls changed the economics of construction and mining. New machines could do the job with less fuel, fewer breakdowns, and smaller crews. The adoption curve was steep, and by the late 1990s, hydraulic excavators had replaced most cable-operated giants on active sites. Museums and preservation groups tried to save a handful of these titans, but the cost of moving, housing, and maintaining a 12 million-pound shovel or a 300-foot drag line was often too great. Most were cut up for scrap, their stories nearly lost. Yet behind every machine stood a team of engineers, operators, and mechanics whose skill and grit made the impossible routine. They designed booms that reached across valleys, kept engines humming through storms, and coaxed precision from steel monsters built for brute force. Their names rarely appear in history books, but the bridges, dams, and skylines of America rest on their work. The legacy of these machines, and the people who ran them, endures in the very ground beneath our feet. The bones of American infrastructure rest on machines few remember, and their legacy shapes every highway, skyline, and city grid we use today. As new technologies promise progress, our foundations grow older and more invisible. What we choose to remember and to forget still determines the world we build next. The future's strength depends on honoring the unseen hands that made it possible. Share your own stories or questions in the comments below.